Hey guys, this is a hydraulic press problem which uses Pascal's principle. It says we got a car of mass 1,200 kilograms, sits on a hydraulic lift as shown above. The radius of piston A is 0.3 meters and the radius of piston B is 0.1 meters. Ignore any pressure effects caused by the differences in heights of the fluids. So what we've talked about before, that pressure due to a fluid is density times gravity times height. These height changes are going to be so little that they're not going to affect the pressure much. Part A here says piston B is pushed a distance of 2.5 meters, raising the car, piston B is pushed a distance of 2.5 meters, raising the car slowly at constant speed. Calculate each of the following. So AI says the magnitude of the applied force on B. So if we are lifting it at a constant speed, then we know that this applied force up from the piston has got to equal the force of gravity down on the piston there. So those two things, sorry that was out of view, must be equal to each other because it's raised at a constant speed. No acceleration, balanced forces there. So in order to do this, let's think about it like this. Pascal's principle says that whatever the change in pressure is over here, this side's got to have the same change in pressure. So we could say like this: pressure at A has got to be equal to the pressure at B. Let's substitute in for each of those. This would be the force on A divided by the area of A, and that would have to be equal to the force on B divided by the area of B there. Next step is to think about what these values are. We know the force on A, it's the weight of the car. So if it's 1,200 kilograms, it's got to weigh 12,000 newtons. The area of this side we'll do by pi r squared. So pi times 0.3, don't forget to square it there. On the other side, we are looking for the force on piston B, and we know that its area is pi times 0.1 squared. Another way you can think about this is proportional reasoning here. So since this one side has 3 times the radius, how much more area does it have? Well, 3 squared is 9, so this one has 9 times the area. That must mean it has 9 times the force. Or you can think about it the other way. This has 1/9 the area, so 1/9 the force. So the force on B will be 1/9 of that. You can do that with proportional reasoning, or you can just work out the algebra, and you'll get that the force on B must be 1,333 newtons there. Let's go on to the vertical distance moved by the car. So another thing we want to think about is as we move this down, if we push like a liter out on this side, there's some change in volume, we would have to push a liter up on that side. That change in volume would be the same value on each side because the water's got to go somewhere. So the change in volume is the same for each. So the change in volume of the A side has got to equal the change in volume of the B side there. When you go to do that, you think about these are cylinders, so their volume is their area of their base times the change in their height, so to speak, right? How far they moved. And this would be on the A side, and that would have to be the same on this, the area of the B side times its change in height. So next line here, we can get the areas again. On the A side, it would be pi times 0.3 squared, and they tell us that the car has moved a distance of 2.5 meters. Piston B is moved 2.5 meters. We are looking for this change of height of A. On the B side, it's pi times the radius squared to get the area, and B is pushed down 2.5 meters. So if you solve for the height of A there, you will get 0.278 meters. So, about a little more than 1/4 of a meter there to push it down. There's another way that I actually prefer to use here is the work you do on each side has to be the same. So the work on side A has to equal the work on side B there. So the work is equal to the force on A times the distance A moves, and that's got to be equal to the force on side B times the distance that it moves. We know that A has to lift with 12,000 newtons to lift the car. We are looking for the distance A moves. And the force on B we already solved is 1,333 newtons, and they told us that it moves 2.5 meters. And either way, you'll get the same answer of 0.278 meters is how far it will move. Last part is calculate the work done. That's sort of, what almost leads you to there. Well, that would just be one side of this, right? The work done on either side is the same. So you could do 1,333 times 2.5, or you could do 12,000 times 0.278. So either way you do it, you'll get that the work is equal to 3,332.5 joules is the answer.